No. Hello.
Yeah, hello.
Yeah, hi.
Hi,
Mm. Yeah, have you started with the assignment portion?
yeah, I'm just searching for the suitable location. I have to ask one question.
Yeah.
Uh, should I take the entire city or a
No,
specific
no.
area? Like,
Any one tile is also fine. See, as far as urban mapping or LULC mapping, you can only work for a very limited areas.
okay,
Okay, like a 5 square kilometer, 10 square kilometer, like that. But for NDVI and other things, you can take one tile. That will be sufficient. Okay.
yeah, okay,
Because in NDVI, you need at least a full tile to show the differentiation and other things. Whereas for LLC, you can just take out any one small portion of the area and you can work with it. Okay.
okay.
How much with the assignment? Like, do you have any doubts in the assignment which I've given you, the Word file or PDF which I've given you? Have you gone through it fully?
Yeah, I read it. Right now, there is no doubt. Like when we started, after started, I'll ask question if I getting any doubt.
Yeah. Okay. So now we'll start with your next topic.
Yeah, okay.
Okay. As a part of your syllabus, you have data quality and metadata, and you have other quality and backend related details of the GIS. Okay. So that we'll be seeing now. Okay, so okay. Yeah. Do you know what is metadata?
Yeah, basically it is a backend data of any data like where data come from.
Okay. The generalized definition what people might understand is like it will be the properties of the data that you have. Like whatever comes on the property portion of the data which you have is said to be a metadata, but it is technically defined as anything that is having when, where, and how the data is acquired. Like that is called a metadata. Okay. So it can be time, it can be a location, it can be a geotagging information or any other particular details regarding the data that you have collected. Okay, so that is the basic definition of metadata. Okay. And as far as your data quality is concerned, you have some important things. One is the positional quality. Okay, next thing is an accuracy. Okay, next thing is attribute. Okay. Next thing is completeness. The next thing is consistency. Next thing is temporal accuracy. Next thing is resolution. So this will be positional accuracy and attribute accuracy. Yeah, okay. Yeah. And coming to the point, these are all the basic data qualities that you can check with any data. Okay, so if you take the position of accuracy, it is considered to be the error proportion with respect to coordinate system. Okay, see for example, we'll tell Google Earth is having 15 to 30 meter errors, where Sentinel data is having 10-meter errors. That means that the position which it is showing on Sentinel data can be 10 meters off from the actual location. Okay, so that is said to be the positional accuracy, which means, the exact coordinate error value. That is, you have collected one data from field and you have collected one data from any one source of data. Okay, so what is the difference between the position of the coordinate which you have collected from field and one you have collected from any open source or any software is said to be the positional accuracy. So here you have two types of data. One is ground data and one is backend data. Okay, so all the ground data that you collect in this case is only for quality checking. Okay, so as far as this part is concerned, there will be mostly no other data used for quality checking. Only the data collected from ground will be considered as a quality checking data. Okay, next thing is the attribute accuracy, which means, the data that you have added with a positioning system. Okay, so you might have taken any data through survey. In that case, the name that you have provided or type of data that you have taken is said to be the attributable accuracy. Okay, so here, for example, you would say you have taken about a building. So here in field, it might be a ground floor plus one floor. But while entering, you might have given ground floor plus two floors. Okay, so these data that you have entered on attribute table should be manually verified with field data to provide attribute accuracy. And as far as this attribute accuracy is concerned, here you will be having percentage. Sorry, you will have percentage of error. Okay, which means like we have taken 100 samples from GIS data and 100 samples on field. So based on how much data that you have entered in the GIS system is wrong, that is converted into the percentage, and you are giving them a percentage error, which means, out of 100, 20% is having the error value, or 30% is having the error value, or anything like that. Okay, and as far as the attribute is concerned, any error value which is more than 5% is considered to be a feedback file, which means, it should be reworked entirely or it should be worked for correction. Okay, the maximum error of 5% is accepted. Okay, so that is the error value. But in the positioning accuracy, it will be considered with the meters. Okay, so for example, a point A is marked here on field, but in backend or anything, it is marking here. Then you will just measure the distance between these two. The same, you will take 5 to 10 ground readings. Okay, the same way, and you compare the distance difference between all 10 readings, and the average of the difference is said to be the result position accuracies. Okay, so here your coordinate will change. Since, if you are taking readings in UTM, it will be on meter scale, so your error will be on meter scale. Or if you have taken it from point, minutes, and seconds, your error proportion will be based on the point, minute, and second scale. Okay, so based on what data type that you are acquiring the position, the format or the derivatives of the output will be changing here. Okay, the next thing is the completeness. That is, this is on completion of work. Okay, this is regarding attaining the full scope. Okay, so this means, see, the same way I have given you a assignment. So when you're able to achieve the full potential of the full scope, that is when you're able to satisfy all the conditions of the scope, then it is said to be a completeness. Okay, so or if you have any left out or if you are unable to perform any actions, like when you are missing like one or two actions, based on the entire project value or project mark or project percentage, each and every part of a project will be having a weightage. Like this will be 10%, this will be 5%, this will be so, like the same way, the completeness of the project is determined based on how much you have completed the project and satisfied the scope of work. Okay, this will also be considered with respect to percentage. Okay, next thing is consistency. So here, the completion of the project is not matter. The evenized work proposal is the matter. Okay, so the basic definition of consistency is to be throughout, which means anything should be evenly and properly planned throughout a particular period of time or anything. Okay, so as far as the consistency is concerned, so people consider consistency when they are executing a very big project. Okay, that is consistency is nothing but showing up on field or being available at all times for any type of work. Okay, for example, if you have given a delivery to a client, so being consistent means you have to follow up him based on the delivery that you have provided, and you have to get details from him. And if there is any correction, you have to follow it up, making sure you complete it and properly deliver it on time. So the consistency means mostly the follow-ups. Okay, like you should be there 24 bar 7 available in order to address issues also or any other things also. Okay, so consistency means we are planning it based on such a way that you will not, there will be no condition where you will not be available to perform an action. Okay, so whenever you are there to perform the actions whenever required, it is said to be consistency. Okay, so that accuracy is said to be consistency accuracy. Here, in part of GIS, the consistency accuracy comes in places of mapping or other things where we'll be providing a client or anyone with a data lake. We'll be putting like 15 to 20 manpower inside their project for working, and it should be consistent that the entire 15 or 20 people whom we are allocating for a project should be present regularly based on the work, and the completion of the work should be consistent. That is, it should be even. It should not have a very big deviation. It should be even throughout the time of starting the project till the time of completing the project. So any project planning should be based on the consistency. Okay. So next thing is the temporal accuracy. Okay, the temporal accuracy is nothing but the data acquired time or the age of the data based on the time. Okay, like for example, you have taken a data and the project again goes for another 1.5 to 2 years, which means the data that you have taken while starting the project will be 2 years old. Okay, then based on the client requirement, it might or might not satisfy the temporal accuracy. So here and everywhere, the temporal accuracy means nothing but the date and time of the data taken and the validity of the data. Okay, so when you go for a GIS data or anything, people used to tell the validity of a GIS data will be for a maximum of 1 year. Okay, because within a period of time, that is 1 year, there will be a very large difference on the areas that you have taken the data. Okay, so it is said to be that within a year, your temporal data gets expired in GIS. Okay, like the same way, the data, if you are running for 5 to 10 years of project, then you have to take the new temporal data every 6 months or 3 months or 1 month based on the requirement of the project. Okay, so here the data should be the latest data which should be acquired from field. It should not be older more than 2 to 3 months while starting a project or initiating the workflow of a project. Okay, so this is said to be a temporal data accuracy. Okay, so the next thing to be considered is your resolution. So here is where the basic definition of what we are using in GIS comes in. Okay, based on the values of a pixel, the resolution, the quality of data is getting determined. That is, the more number of pixels, the more quality of data or more information that you can acquire from a data. So the resolution is entirely based on the quantity of information that can be acquired from the data that we are using. Okay, see if you are using a data which you are acquiring too many quantities of data, then it is said to be a good resolution data, which means there will be so much pixels so that the quality and the quantity of data that you take from it will be too much accurate and it will be easy to validate also. So that is where the resolution comes in. Okay, so these are the basic types of like accuracy of data. Here that we'll be using based on the location of or the type of project that we use. Okay, so it will be like that only. So based on these data, based on different data that we have collected from field, from backend and everything, the accuracy of any data that you provide will be subjected to acceptance or not. Okay, so for example, if you go for Indian Bureau of Mining or Survey of India, their maximum error percentage should be less than 5 centimeters. Okay, but if you go for state government projects, their accuracy will be determined at a rate of maximum of 10 centimeters. Okay, so these are the standards that have been implied by the government as a standard of quality check on every government and private projects. Okay, mostly on all private, like the government projects in railways and other things, will be having a maximum data accuracy permissible limit of 5 centimeters. That means the data that you have taken from field and the data that you have prepared on the backend should not have a difference value of more than 5 centimeters with respect to field. Okay. And these accuracies can be acquired through various project process. Like when you go for digital image processing, you can use ground control point, or if you go with the AutoCAD or photogrammetry work, you can go with a field survey along with a digital survey. So in that case, you will have two different types of data in order to counter verify both the data. Okay. So this is the basics about how to create or what is accuracy on a GIS file. Okay, so based on the client requirement, the type of accuracy that you will consider should be confirmed and should be approved by the client. Okay, sometimes the client might tell the data should be the latest. In that case, you will be only consistent on the temporal accuracy rather than other accuracies. Okay, so here, based on the client only, the accuracy format that you use will be determined. And as the same part, there are some obligations where a client or anyone who's giving you a project or who's executing a project might determine a testing procedure also. Okay, for example, in temporal accuracy, they might look out for the metadata of the project in order to properly identify the time and other things of the project. Okay, the same way they can use measurement tools in order to identify the resolution accuracies. Okay, so based on each and every project that we have, the client might give you a procedure to check quality also. It is not like only you are subjected to check quality of the data based on the details that you have. The client will give you a proper procedural thing in order to check for the quality of the data, and which you should be subjected to follow in order to attain the quality that is being required by the client. Okay, so these are the basics of quality of data. Do you have any doubts still here? Okay.
No.
Yeah. Okay. So as part of your second syllabus, we will be covering about what is metadata and other things. Okay, and in the meantime, I'll also define why it is important and how these evaluations are done and other things. Okay. So as part of quality, okay, it is too much, yeah, it is too much important because if you change the quality of data, the output changes. Okay, so there is a very big difference between, for example, if you are going for a rainfall analysis or if you go for an urban planning analysis or anything, if you have taken the most accurate data, the quality of output that you provide can be that much accurate as compared to input data. But if you go for a different quality, for example, when you use the NDVI calculation to a Sentinel data and Landsat data itself, for same particular zone, you might be able to know, like, identify all the differences between these two because Sentinel data's accuracy is different and the Landsat data's accuracy is different. And it is 99% that the accuracy of the input file is what determines the accuracy of the any output file that you are determining. Okay, the next thing is the reliability. Okay, so when a data is being highly reliable, which means The data can be blindly trusted by any one person in order to come to a conclusion or in order to execute a workflow or anything. Okay, so these reliability comes with the quality of data only. People rely on agencies or government rely on private agencies to execute a work due to the reliability that they have with the government. That is, the reliability entirely comes with the quality of data that the client is being submitting to the government agency. Okay, for example, if he is not giving a proper quality of data, then the reliability between the quality of the data and considering that agency or organization for project will also get drastically reduced. Okay, so this is called the reliability of data. Okay, so next thing is the decision making. Okay, once it is highly reliable, people can depend on it for any type of decision that they want to take. For example, no, if it is a urban sprawl analysis or urban mapping analysis, government are planning sanctioning schemes each and every day. Okay, so when the data is more accurate and reliable, the decision making process of the government is made easy. Okay, not just for the government, even for you. For example, if you're working for a site suitability analysis, okay, and you suddenly come across a difficulty that a data is not reliable due to some technical issues. Okay, so then you will not be able to bring it to a conclusion or prepare a final report based on what you can conclude with the data quality. Okay, so it is very much important to get this quality and to make a decision making skill. Okay, so here the reliability defines everything and the quality of the output. Okay, so that in case, so it will be the quality of the input data that you are providing should be high in order to get a very good high quality output based on which it will be reliable for every use, and based on that reliable data government and private agencies can take decision at minutes of time rather than working full time on field. Okay, the last thing is the errors. Okay, so as we are telling errors, there are two type of errors. Okay, the first thing is a low budget error, and the next thing is a costly error. Okay, so low budget error is nothing but you are a company, you only work for backend for any one or two companies. When a agency trusts you with the data, the quality of data that you provide them is too bad, and they'll give you one or two chances to correct the quality, and after which they'll just cancel the contract. So for that agency who has given you the project, it will be a low cost error. Okay, but for an agency who have taken up the project, it will be a costly error, which means you have invested too much regarding a project and you are getting zero returns out of the project. Okay, so here there are possibilities of costly errors like misusing or misinterpreting data from field, which might even cost you the entire data that you have collected. Because this has happened to me personally. I have taken like a survey for a few areas, okay, during a particular project. And while taking for the quality and data what we have collected, we have shifted the projection to a wrong projection. Okay, so then we have executed the field work for entirely 2 days. Okay, so only then after 2 days when checking for QC, we found out that the quality and the projection and everything is a different one. Then again, it was a costly error for us, which means I have to again deploy the entire ground team for 2 days extra than what we have planned in order to take the actual data. Okay, but for client who's given me the project, it is not his costly error. Okay, it is not even a low consumption error for him. It is not even considered from his side. But I have to extend a team. I have to look after their stay, accommodation, food, and everything based on the error. Okay, so the cost reliability, and it is not always that you will have a sufficient backup financials to execute a project the second time. Okay, if you are working for the government agencies or government departments, it will be always a one-time work. Okay, like you cannot extend the project or you cannot again go to field for resurvey. Okay, it is always a single time visit or survey before completing or executing a project. Okay, so based on this financial condition also, the quality of the project or the data that we are taking should be highly important to us. Okay, and next thing is how our data quality is getting evaluated. Okay, so we have basic evaluators like we have geometric errors. Okay, we have topology errors, we have attribute errors, and we have raster quality error. Okay, so these are the four types of errors that we have. Okay, this is geometry. So here the geometry error means the drawing might be if it is digitalizing. For example, a geometry error means we have digitalized the wrong portion or we have moved a line to any one side while digitalizing. Okay, which means you have digitalizing fences and you have miscalculated and you have missed one fence or you have wrongly digitalized one fence where your drawing is not matching perfectly with the data. Okay, so these type of errors are said to be the geometric errors. Okay, so here in order to check and rectify these errors, it is always a manual work. Okay, so not just this, any type of geometric error that you take, it should be manually checked. Okay, but based on the type of error that you consider for checking, the work that it involves will be reduced. Okay, as far as geometric error is concerned, you have to have a even more keen eyes. It should be a full-on manual checking. Okay, so from zone to zone, from file to file, from polygon to polygon, from feature to feature, your geometric error will only be rectified if you are entirely checking the full file. It will not be a random checking, it should be a full file checkup. Okay, which is also a very large time consuming process as compared to all other checking procedures. Okay, so here you will be having issues with geometry features or anything related to the geometry of the feature. Okay, so till this, do you have any doubts, Yogesh?
No, not right now.
Okay, the next thing is for your attribute errors. Okay, when it is coming to your attribute error, sorry, next thing is a topology error. Yeah, when it comes to your topology error, you have conditions. Okay, must not overlap or must not have gaps or must not have duplicates. So there are so many conditions in order to clear the topology correction works. Okay. So based on the file that you have provided, the error type changes based on which the error is being executed. As far as your topology is concerned, you can automatically check for errors using the tools, which is the basic topology tools. And again, to the same part, the rectification process is a manual process. Okay, so you can only check for errors through automatic processing, and all these checked or error marked areas should be manually corrected with the help of human resource only. So there you cannot rely on system or automatic or any type of semi-automatic things in order to determine the quality of the data. Okay, or in order to rectify the errors. Okay. So here it might show, for example, if you have a gap or if you have overlaps or anything, it will show that region to be on red color or any other color as prescribed by the user. And again, once the tool is executed, it will check every zone for all errors and that will be listed into an attribute table or any type of shapefile or anything, which can be again enabled or edited by the user to rectify all these errors to remove the topology checks. Okay, the next thing is the attribute table validation. Okay, so here you have two different types of attribute table validation. One is clearing a null values. Okay, which mean when you have selected a feature or anything, the first thing that happens after you digitalize a feature or when you enter a feature is it's a null value. Okay, then you have to check for if there is any null values and rectify those null values with the appropriate values. That is, it can be anything. It can be a name, text, format, number, or anything. Based on that, you have to rectify your null value. Okay, because we most people will provide null values in order to identify these type of hindrances also. Okay. Next thing is a duplicate record. Okay, when you go to attribute table, there are so many possibilities like every data that they have taken is a duplicate data. Okay, which means the data might be there on field already and they might have just copy pasted it in order to complete a report or finish off a area. So in that case, the duplicate entries and duplicate reports will be more, which you can use Excel in order to identify the duplicate values, or there are some specific proprietary softwares in order to identify duplicate values in any type of data that you provide them. Okay, the next thing is the checking for duplicates. The third thing is incorrect entries. Okay, so here is where your data collected from field comes into play. Okay, that is, you might have taken a survey from the field. Okay, so you have to check for incorrect entries. That is, a person who's taken the same data in field when seeing a data prepared from the backend team can easily identify the errors done by the backend team. Okay, which means you have to know knowledge of the field and the location where you are conducting the project or you are experimenting the project or where you are proposing the project. Okay, so you should have a constant site visit and you should know the environment of the location in order to identify these type of incorrect entries. Okay, so these entries are mostly, people will not identify due to so many factors, but at the end, these are the main important readings that you will be entering. For example, if you go work for land revenue department or anything, so each and every entry will have a door number two, its a feature and land tax and everything. Even if you wrongfully entered a zero or one in a survey number or payment terms or anything, the entire land revenue department itself will go into a chaos. Okay, so here you have to verify each and every entry before making it live or before making correction. Okay, so those entries and all you can either delete it or rewrite it into a correct entry. Okay, next thing is a raster data quality. So when it comes to raster data quality, there are only two things. First thing is a resolution, that is how many pixel by how many pixel, and what is the accuracy of the pixels. Okay, so this is the first accuracy. The second accuracy is a cloud cover. Since you are extracting data from Google Earth or anything, the main important thing is your cloud cover. Okay, so the data that you have collected should not have more cloud cover, that is, should not have more than 10%. Okay, so based on the project, the ranges might vary, but it is not advisable to carry on with any cloud covered or region where there are too much cloud cover on the region. Okay, so as far as your raster quality is concerned, when you're downloading a data, the cloud cover is too much important in order to perform actions. Okay, because wherever cloud is there, you will not be getting it on the multi-band because it will be fully white or it will be clean. Okay, so the cloud cover is most important in order to identify any classification. Next thing is a band alignment. Okay, so when we speak about band alignment, it is that the Landsat is having minimum of 12 bands. Okay, but Sentinel is having minimum 4 bands. So here the band alignment. So each and every type of band that has been emitted by a satellite or sensor is having a different type of receiving end. Okay, so these band and all we have to have. Okay, so we have to have this band element in order to accurate, like get a maximum accuracy output and maximum raster quality. Because if all the band is all properly mentioned or named, then again you can easily create color images or layer stack images from all the bands given. Okay, so the alignment of the band should be even throughout the file with respect to all the features that continues with it. Okay, so these are the different types of evaluation process that one can do in order to check for the qualities. Okay, do you have any other doubts?
No.
Yeah, and there are also some specified tools in QGIS like fixed geometry and locate geometry and other tools. As we have seen about the basic toolbox of QGIS. So based on that, you can use these automated coding tools in order to make your work also even easier. Okay, so previously it was very tough for engineers in order to identify errors on a completed file. So in this case, you'll have a very good possibility of identifying each and every error file so easily so that now you can easily fix it with the help of another tools in QGIS itself. But it is not like the tool will be 100% correct, but it will be reducing your work to 10 to 15%. Okay. Based on the location and availability of the GPS coordinate system and other things, the quality of data will be changing, and based on that, everything will be determined. Okay. That is based on the quality, you can use the different tools in order to attain a even better or very good quality also. Okay. As far as this quality of data is all complete, we'll be seeing about what is metadata. Okay. So metadata is simple, a, a file or a log or anything having details about a data. That is a backend detail, which means when it is staked, where it is staked, and at what time or at what location. So these type of basic things only the metadata answers. Okay, and you cannot actually edit or do corrections in the metadata because all the metadata that we work will be systematically generated from the software that we use itself. Okay, so in order to, you can edit the metadata, but you need a proper valid license for the softwares, or you can change the properties of the software in order to edit the metadata. Okay, so have you seen any metadatas in your life, Lokesh? Or have you studied the metadata of any file properties or any file type or anything?
Uh, Not that much. I have seen only, not working on metadata properly.
My screen is visible, right?
Yeah, it is.
Yeah. Okay. See, there is one option called metadata, which is actually this. Okay. See, this is the entire metadata that has been present on the entire image. So my screen is visible, right? So when you come to this portion, the first thing is a file name with a location. Okay. So it is on the D drive. This is the folder which I have. This is a subfolder. Then again, this is a subfolder. And based on that, I'm having it on that location. Okay. The next thing is the description, which means only the name of the file and a file type. Okay, so if it is of any, since it is a ECW file, it is showing .ecw. So if it is Excel, it will show .xls or any other CSV or any format in which I have saved the file. Okay, the next thing is a boundary. Okay, that is upper left. Okay, so here the upper left means consider this to be the right portion and this to be the left portion. And there, as compared to this, they'll have one toolbox here. Okay, like there will be one toolbox like this based on the boundary of the image. Okay, so once this toolbox is generated, it will be like it will have its own area and other things. Okay, so I'm just creating a. So this will be like the file of the. Okay, so this will be the image name or number or anything. Okay, so the top left will be this portion, not here, it will be here. Okay, the same is for, again, you have top left, upper left, you have two coordinate here. That is in x coordinate and y coordinate. Okay, so you will have x coordinate separately, y coordinate separately. The same you will be having lower right, then again west latitude, north latitude, south and east. So this is the boundary of it. Okay, as compared to x and y. Next thing is the directions. Okay, so when these directions come into play, the center point will be considered and it will be like this. Okay, you'll have two lines here, like plus. Okay, so based on the line. Okay, so here we'll be having two different lines. Okay, so this will be the northmost point. This will be the southmost point. Again, the same. This will be the east point and this will be the west point. Okay, so these are the basic things of this one. Okay, then the next thing is a UL corner latitude and longitude. Okay, so this is the same. Okay, upper left UL. Okay, UR is upper right. Okay, so this will be upper left side, upper right side, lower right side, and lower left side. Okay, so based on that, you have all eight coordinates. Okay, based on x and y, the entire boundary of the file is being marked. Okay, the next thing is a project projection system. Okay, so here I have projection system as UTM zone 44 in WGS 1984, and the unit of it is meters. Okay, so this is the projection description. The next thing is a projection datum used. I have used WGS 1984 to acquire this projection. Okay, and this is a projection unit is meter. Okay, so all these two things together will be added as a part of projection descriptions also. Okay, the next thing is the EPSC code, okay, which is none other than the projection code of the geographic coordinate system or the vertical, the geometric coordinate system or the vertical coordinate system. Okay, so this will be the code. So it means 32644, which means 326 means it is WGS 1984 and 44 means the zone of north. Okay, so this is a description of this code. And some people use this code in order to get even more different descriptions based on the type of work that they are doing. Okay, the next thing is a box area. That means the entire box of the boundary, whatever they have covered, it is calculated the area for it, which is somewhere around 1 to the hundreds. Okay, yeah. So it is somewhere around 4 crore 48 lakhs 83,238 square meter. Okay, and this, if you want, you can convert it into square kilometer also. So that is entirely based on your requirement of what you have to do it. The next thing is a load time, which means that is the time taken by the software to open the entire full file from dragging it in or selecting open. Okay, so that is 0.28 seconds. Okay, the next thing is a file creation time and file modification time. As far as the file creation time, it will show you the details of the first time the file is being tried to create. Okay, for example, when you're creating a new Word file, it will show you time of creation is somewhere around today or something. But after working for 1 hour, it will come into the file correction time or the file updation time, modified time. Okay. So this is the last time we have accessed the file and I have done some corrections or modifications on the same file. And this is the time at which the file is being created as per my computer. Okay, so my computer, it is 548. Okay, based on that, this file has been numbered. Okay, so this is said to be number of columns and rows. Okay, so this comes with the backend production data of what I have. Okay, so based on number of resolution or other things, the number of rows and columns will be determined. Okay. The next thing is the number of band, which means if it is a multispectral data, it will give too many number of bands. But since I have only used a camera, it is showing three bands, which means we have red, green, and blue band. Okay, see the color band is 0, 1, 2. As far as this software is concerned, it can be RGB, but the numbers are different based on the software. Okay, this is a pixel width, that is, it is like 2 centimeter per pixel. Okay, so this item you can actually customize. Okay, so I wanted a 2 GDS, GDM, or 3 or 4 or 5 based on whatever data that you can acquire. You can actually determine the quality of the pixel. Okay, the more or less value that you give to the quality of the pixel, it will be a more hard time to transfer the data. Okay, the time limit might get too much issues with transferring data when the pixel is too big. Sorry, when the pixel is just too low, the number of pixels accompanying a particular section of the map will be too big. So based on that, the quantity of the data type, that is, if it is normally in 2 GB or 3 GB, it will go up to 4 to 5 GB based on the quality of data and the time being that it is being take to get into that location. Okay. Next thing is the bit depth. Okay, so when you come to the depth, it is the average between the topmost point and the bottommost point of an image. Okay, so this some people might describe it as a different depth also, but when it comes to survey related work, that photogrammetric depth or image depth will not be considered. Only the difference between the maximum altitude and the minimum altitude of the location will be considered. That is the maximum depth of a location based on the signage and the location that you are there. Okay. Next thing is the sample type. Okay, that means what is the type that it is being used in order to transfer this data or work on this data. See, they have taken bit sample type as unsigned 8-bit integer. Okay, so which means all the numbers that I have provided is an integer and it is using an 8-bit decoder in order to acquire that data. Okay, so when you go to a computer, it is having so much type of decoder like 8-bit, 16-bit, 32-bit, 64-bit, and every other things. Okay, so based on the quality of the output generator that we are having, the sample data will be from 8-bit to 16-bit or 24-bit or 32-bit based on the total availability. Okay, the next thing is a projected name. So previously we have seen what is the projection description. Now the name of the projection when you want to search it for the next time. Okay, so that they have given. Next thing is a datum name as per the projection. Okay. So mostly your datum name and projection name will be same unless and until they update the coordinate system or they update your zone or they update some demarcation or anything. Okay. The next thing is the target compression. That is 1:10. That means when I am compressing a TIF file into an ECW file, I am only considering 1/10 of the quality of the GIS file to that of an ortho file. Okay. So here the comparison happens. That is the difference between the quality of the image data that you have produced with respect to the data quality that they have submitted or created a bond or it may be anything. Okay, so any detail that is having all these details about a file or and maybe it can be a source or anything, then that is considered to be a metadata. Okay, basically people will see metadata only in the property section where they'll be seeing sharing and security. Okay, this is the actual metadata what people are using and what people are still trying to finalize and approve any type of metadata projects. Okay, so these are the basics of metadata. Do you have any doubts till now?
No.
Yeah, okay.
Yeah.
So these are all the full issues regarding basic definition of accuracy, what are the accuracy types, and what are all different standards that people are using in order to identify the data quality accuracy. And the next thing is what is a metadata And what is the metadata in QGIS or any GIS data? Okay, and in order to acquire a proper metadata or a proper quality of data, there are so much agencies in India like QCI, which is Quality Control of India, or ISO. And if it is a university or something, they might have a current auditing year through university or something like that. And all these things comes inside the metadata properties. Okay. Do you have any doubts till now?
Not from my side. No.
Yeah. Okay. The next basic thing that you wanted to know is a geo package. Okay, it is all like definitions only. Okay, so I'll just tell you basic things and we can discuss it wider later. Okay, G P K G. That will before a dot. Okay, so this is a file type called a geo package. Okay, so whenever you are executing this geo package, it is almost like a database. Okay, it can be in a file or GDB or any database type of file format where you can store raster data, vector data, metadata, and attribute data. Okay, so any format where it can store all these four types of data is said to be a geo package. Okay, which means the word basically defines anything which is having more than one data type for a particular zone or a particular area or particular type. Okay, it is like a combo offer or a combo set. Okay, where the package is having raster data, vector data, attribute data, and other data types, whichever is required by a client or whichever is required for performing a specific action. Okay, this format is said to be a geo package, and when you are saving GeoQGIS file, like after loading all data and other things, you can either save it as a geo package. That means it will be easy for anyone to create it, use it, and everything. Okay, but you have to be extra careful while creating a GeoProject file because sometimes it might be tricky and you might face some complications like projection issues and everything because when you have created a geo package, every data that you put inside that should be of same projection, should be of same type, and there are so much constraints with geo package on how you can create it. Okay, so when anything that comprises all your vector data, raster data, and your attribute data and every other things, it is said to be a geo package. Okay, so a package which contains all these data all together at once. Okay, do you have any
Yeah, okay.
doubts still here, Yogesh?
No, not right now. No.
Okay, so if you don't have any doubts, we can wind up today's session with this itself, and we'll be seeing even more detail about every metadata and geo package and everything from your next class. Okay,
Yeah, okay. Uh, uh, can I ask you one question?
yeah, yeah, definitely.
Can can you suggest some area like where to work? Like I'm confusing right now.
Okay, yeah, I'll just give you some suggestion options.
Like you mentioned, there is a urban area and
Yeah,
like
that is what. See, so just I wanted you to select a zone in such a way like you can select metropolitan cities to be precise. Okay, so you can select, for example, Bangalore if you're selecting. Okay, so mostly as far as Bangalore is concerned, the entire Bangalore comes in a single tile. But if you are able to select zones outside Bangalore, like these international airport or any other zones, okay, so here you can have your urban file as well as vegetation file. So mostly look out for city areas or see anywhere like this. So you have a vegetation file and you have a build-up file. So when you're able to differentiate between two different zones, if you go to Chennai or any other person, okay, any other location, or mostly go to the head of states. Okay, so you can go to Hyderabad or anything. Okay, see, even suddenly outside the city, you will have a different vegetation and everything. See, when you take this particular zone, you have a full vegetative zone also, and you have build-up zone also. Okay, like when you're taking these type of zones, you'll be having even more features. Okay, like mostly select the outskirts of a metropolitan city because it will be easy for you to identify and differentiate features at a very large scale. Okay, see, for example, if you're taking somewhere around Delhi or someplace, anything, no, there are possibilities like, no, when you see the outskirt of the cities, there is a possibility to have a full vegetative zone utmost near to the boundary of the existing metropolitan cities. Okay, so you can select mostly like that. Okay, just select a state capital or anything. Just look out in Google Maps for any particular zones where there is also vegetative index as well as this. Okay, so just try it out with Hyderabad or Bangalore or Delhi or any capital of a state. Okay, then the possibility of you finalizing a zone will be easy because you'll be having the same build-up area and everything on the city limit, and suddenly after that you'll be having the full vegetative zone. Okay.
Uh, like if we are taking a random area like out of city, so we have to create our shape file first.
No, that is what if we are that is what I told you. If you are unable to manually verify any data through that, just
Yeah.
download data from OSM software. Okay. Just manually verify those with Google Earth or any available source, Google Maps or anything. That's all. Okay, because it
Okay.
will be like not all the time you'll be able to access the data. See, if you are in Bangalore, right? What is your current location, Yogesh?
I'm right now Noida, 134 sector.
Okay, see, you're in Noida. So when you go to anything related to your residential area, you'll be able to take data or verify the data. But if you're taking somewhere near Hyderabad or Bangalore or West Bengal or somewhere, it is easy for you to rely on OSM data and Google Earth. Okay, because now we have 3D views in Google Earth and everything, and you have most of the data is marked out by OSM software. Like, no, it will be differentiated like build up area and everything. Okay, so these data is all having different data types, like what you want. So if it is the area is inaccessible to you, just collect the data from any software and manually verify, like do a random checking. Okay, so just take 100 samples or 100, just select 100 buildings. The same zone, check it with a Google Earth or Google Map or something in a street view or anything and verify the data. And based on the verification, you can provide with the accuracy data. Okay, like you can provide a quality report also that this data might be this much percentage accurate with ground data or anything. Okay,
Yeah.
yeah, okay. Do you have any other doubts other than this?
No.
Yeah, okay. If you don't have any other doubts, we'll wind up today's session with this, and from tomorrow we'll be seeing in detail about the geo packages and metadata and other details. Okay?
Yeah. Okay. Thank you.
Yeah, okay.